All right, welcome to the Explainer. If you've ever had that itch to build software, to create something from nothing, then you're in the perfect spot. Today, we're going to grab our virtual hard hats and tool belts because we are building our very first C++ program, right from the ground up.
So, ready to get your hands dirty? Good. Look, we're not going to waste time with a boring agenda. We're jumping right into the action, right into the most important thing, the blueprint for our program.
You can't build a house without a blueprint, right? Well, it's the same deal in C++. This right here, this is our blueprint. Now, I know it might look a little intimidating at first, but don't worry. We're going to break it all down piece by piece.
So this is what we call boilerplate code. You can think of it as the absolute non-negotiable foundation and framework for any C++ program. Seriously, you're going to be typing this stuff out so often, it'll practically become muscle memory.
Okay, let's look at that first line. #include IOStream. What's that all about? Well, imagine you're telling your construction crew, hey, go get the toolbox for installing windows and doors. That's what this line does. It brings in a library of pre-built tools, and the most important one for us right now is count, which lets us, print stuff to the screen.
Next up, we have int main with these curly braces. This is, well, it's the main event. It's the front door to our building. The program's entire life happens inside these braces. Anything you want the program to actually do has to go in here. It's the official starting line. When you run your program, the computer looks for main and says, okay, this is where I start.
And right inside main, we've got our very first real instruction, cout, which literally stands for character output, is how we get a message to show up. And see those two little arrows? They're pointing the text, hello world, out to the screen. It's a great way to remember what it does. Oh, and that semicolon at the end? Super important. Think of it like a period at the end of a sentence. It tells the computer, okay, this command is done, move on. All right, so we've got our blueprint all written out. But a blueprint is just, well, it's just a piece of paper, right? It doesn't do anything on its own. It's static. So now we got to flip the switch and actually bring this code to life. And that's a pretty straightforward two-step process. First, we compile it, and then we run it. Compiling is like having the chief engineer look over our blueprint, checking for any mistakes. Once it gets the green light, we can run it, which is like the construction crew showing up and actually starting to build.
So yeah, that first step, compiling, it's basically a translation process. It takes our human-readable C++ code and turns it into machine code, the only language your computer actually understands. And trust me, it's also your first line of defense against mistakes. If you forget a semicolon or something, the compiler will scream at you. It's picky, but it's your friend.
And then, step 2, we run it. This is the moment of truth. You're telling the computer, okay, execute that code you just made. It's like flipping the main breaker in our brand new building and watching all the lights turn on for the first time. And when you do that, bam, you'll see Hello World pop up on your screen. Okay, awesome. Our program works. But let's be real. Just printing Hello World is cool for about 5 seconds. To do anything actually useful, our programs need to work with data. And to do that, we need a place to put it. Containers for all our building materials.
And that's where variables come in. The easiest way to think about a variable is just like a labeled box. Seriously, you give the box a name, say age, and then you put a value inside it, like the number 25. That's it. Behind the scenes, that box is just a little chunk of your computer's memory that you've claimed.
Now, you wouldn't build a whole house out of just glass, would you? You need different materials: wood, concrete, steel. Well, data works the same way. We have different data types. This just tells the computer what kind of information we're planning to store in our variable box. Is it a whole number, a number with a decimal, maybe just a single letter, or even a simple true or false? Choosing the right one is key to building strong, efficient programs.
So we've got our containers, our variables, and we've got our materials, our data. What's next? Well, we need tools to actually do stuff with them. In the world of programming, we call these tools operators. They're what let us perform actions on all our data. And the first few tools in our toolbox are going to look super familiar. I'm talking about the basics you learned back in math class. Addition, subtraction, multiplication, division, they all work exactly how you'd expect. The only one that might be new is that little percent sign. That's called modulo, and all it does is give you the remainder of a division. Super handy sometimes. Okay, quick heads up, because this one trips up a lot of beginners. Be really careful with division. In C++, if you divide two whole numbers, two integers, you get a whole number back. So 5 divided by 2 isn't 2.5, it's just 2. It doesn't round or anything fancy, it literally just chops off everything after the decimal point. Gotta watch out for that.
All right, here are a couple of cool little shortcuts, the increment operators. They're just a quick way to add 1 to a variable. But, and this is a big but, the order matters a lot. If you put the plus signs before the variable like plus plus a, it updates the value first and then uses it. If you put them after, like a plus plus, it uses the old value first and only updates it after the fact. It's a subtle difference, but it can make a huge impact.
Okay, let's put all these pieces together. I mean, the real power of a program, what makes it truly useful, is when it can interact with a person, right? It needs to be able to take some input, do something with it, and then show a result.
And that brings us to this simple 3-step life cycle. This is the heartbeat of pretty much every program you'll ever use or write. 1. Get some input from the user. 2. Do something with that input, perform an action. 3. Show the output, the result. That's it. Get input, process, show output. It's a simple idea, but it is incredibly powerful.
So for step 1, getting input, we use a command called sin. You can think of it as character input. It's the mere image of count. It basically just pauses the program and waits for the user to type something and hit enter. And notice the arrows. This time they point away from sin, funneling that user data into our variable. Pretty clever, huh?
Then comes step 2, the action. We can take that age the user just gave us, use our trusty addition operator to add 10 to it, and then we store that brand new result in a completely new variable, which we'll call future age.
And finally, step 3, show the output. We just pull out our cout tool one more time to display the value of future age right back to the user. And that's it. We've completed the full circle. We took input, we processed it, and now we've shown the output.
And really, this is the big idea I want you to walk away with. That simple pattern, input, process, output. That is the absolute core logic behind pretty much every single program you will ever build. Once you truly get that down, you have the fundamental building block to create just about anything you can imagine.
So there you have it. You've got the blueprint, you've got the materials, and you have the basic tools. The only question left is, what are you going to build first? That's all for this explainer.